Hi everyone. By the end of this video, you should be able to find the surface area of composite figures. A composite figure is just a figure that is made up of more than one three-dimensional shape. Now, why do you need to know this? Remember, we're doing the inflatables project, and your goal is going to be to design the coolest shape possible. In order to make a cool shape, you're going to hopefully want to try to put multiple shapes together, such as this figure over here that's got one shape on top and bottom, or this one that's made up of a bunch of pyramids, or this one that's got like two hexagonal prisms and a cube in the middle. So if you can put shapes together, you're going to get a really cool product. So this video is extremely important. So an example is to find the surface area of this shape that's made up of a rectangular prism and a cone. And what I want you to do first when you are going to find the surface area of a composite figure is to kind of just separate each shape and figure out how you'd find the surface area of that piece. So the first piece is a cone, which looks something like this. And the second piece is a rectangular prism. So the front base here is a rectangle. And then the sides are rectangles as well, because it's a rectangular prism. I'm going to do my best to draw what I see here. Looks something like that. Okay, it's not perfect, but you get the idea. Now remember, the surface area is, if I were to cover the shape with wrapping paper, how much wrapping paper would I need? Now the reason that's important to think about is because it's just going to be the outsides of this shape. Okay, and if you think about it, if this cone is sitting on top of this rectangular prism, I'm not going to need any wrapping paper to cover the base here, because the base is sitting on the rectangular prism. So the surface area of this shape, I'm going to need the lateral surface area of the cone, so just the lateral surface area of the cone, because the only thing that would get wrapped in paper is, what's not sitting on the rectangular prism, which is just, the curvy part of the cone. Now, in terms of the rectangular prism down here, I want to figure out what I need to cover up, and I would pretty much cover the whole shape. There's only one chunk that I wouldn't cover up, because there's really like a circle that's sitting on top of here that's covered by the cone. So I would want the surface area of this whole thing except for this. So none of this part should be included. Okay, because I don't even see that. That's not on the surface because it's being covered by the cone. Okay, so putting that together, what I'll have to do here is just find the lateral surface area of the cone. And what I'll have to do here is find the whole surface area, but remove or subtract this piece here that I don't want. Okay, so right now what I'm doing is highlighting the pieces that I don't want. Okay, so step one, you always want to kind of separate them. Step two, you want to figure out what pieces you're going to include and what pieces you're not. And step three would then be to calculate what you need for the surface area. So for the cone, I just want the lateral surface area of the cone, which is everything but the base. So the lateral surface area of the cone, we know now is pi times r times s. Okay, this is the formula for lateral surface area of a cone. So if I unfolded this, it would look something like this. I'm not including, though, the base, so I'm just finding the surface area of this, like, kind of triangle party hat shape over here. In order to do that, I need to know the radius, and I need to know the slant height of the cone. So this cone stretches from edge to edge of the rectangular prism. And if this length is 10 here, then this length is 10. So 10 is the distance all the way across this top rectangle here, which means 10 is then the diameter of this cone because it stretches from edge to edge. So if this is 10, this is 10, this is 10, so on and so forth, which makes the radius of this then half of that. So if the diameter is 10, the radius would be 5. So I can go ahead and plug that in. So it'd be pi times 5 times my s. Okay, the s is the slant height of the cone, which is the diagonal distance on the surface of the cone. Now, I don't know that slant height. It wasn't given to me. All I know is that the height of the cone is 12 meters. Now, the height is if I started at the apex and dropped perpendicular to the ground here. So, therefore, in this particular problem, you will have to solve for the slant height because I need to know what's the height on the surface, not the height in the middle of the shape, the slant height. In order to do that, you see if I have the height and I have the radius, this kind of sets up a sliver of a right triangle here. So I'm only going to set up my right triangle if I need to find the slant height. Because I know that this height is 12. I know that the radius is 5, so that's like from here to here. And then I can find the slanted diagonal distance, which is the hypotenuse. In order to do that, I'm going to use Pythagorean theorem. So a squared plus b squared equals my hypotenuse squared, which is c squared. I'm going to simplify this up quickly since we've done this for so long. This is 144 plus 25 equals c squared. If you take 144 plus 25, you get 169 equals c squared. And in order to get c alone, you have to get rid of the square. So 1 under the square, the answer is the square root. If I take the square root of both sides, you'll get c, because those cancel. The square root of 169 is 13. So now I'm going to plug that in for my slant height here. So my radius was 5, we figured that out. My slant height is now 13. So the lateral surface area is pi times 5 times 13. If I want that exactly, I'll just multiply 5 times 13, which is 65. And I'll leave the pi if I want it exact. If I want it approximate, I'll multiply by. Okay, so the approximate answer I plugged in my calculator multiplied by the pi key is 204.20. And of course, that's meters squared because we're talking about surface area. Okay, so that's just the lateral surface area of the cone. To find the composite figure, I need to find the rest of the surface area that I'm talking about. So I need to find all that stuff. So basically, that's a rectangular prism, except for that circle in the middle that we don't want. So let's just find the surface area of the rectangular prism. So pretend that, that circle wasn't there for a second. And how would I find the surface area of this? Okay, in order to do that, I'm going to label my dimensions. So this is a 10 by 6 square. This is 16. Remember, I always want you to draw the net if you're finding surface area. So I'm going to go ahead and do that. My base is a 10 by 6 rectangle. Okay, that's this front rectangle here. Then I've got this long one that's like branching off the back up top here. And if this is 10, this is 10. So this is 10. And the length of this side is the same as the length of this side because these are congruent. So this would be 10 by 16 rectangle. Okay, then off this side, I have another rectangle over here. So this side I drew right here. So let's draw another rectangle over here. Okay, now if this side is 6, then this side is 6. So 6 and 6, and the length of this rectangle is 16. Okay, then off this side over here, I'd have the same rectangle because you'd have opposite rectangles congruent. So attached to this side, I have a 6 side here because those sides are congruent, and then that would also be 6 by 16. Now, this top rectangle would have the same congruent rectangle underneath it. So underneath it, this base would be 10, and the distance back would still be 16. So I have another 10 by 16 rectangle. So you have 2 10 by 16 rectangles and 2 6 by 16 rectangles, but that's only 5 rectangles. Remember that the bases are always parallel and congruent. So if I drew on this rectangle here, I should have one more of those. That's like back here. It's just not drawn on for you. So I have one more of these rectangles. I'll just attach it over here. So this side has to be 10. That looks like a 16, so I'm going to fix it. That's a 10. Now, the height of the smaller rectangle was 6. Okay, to find the surface area, I'm just going to find the area of each face and add it up. So we have these 10 by 6 rectangles here, that's 60. This is 60. And then we have a 10 by 16, which is 160. I've got 2 of those. Then we have these 6 by 16, which if you multiply 16 times 6, you'll get 96. So remember the area of a rectangle is just base times height. To find the total surface area of the rectangular prism then, I'm just going to add up all the faces, which if you add up all those numbers, it's going to be 632 meters squared. Okay, the only problem with this number is, remember, I'm trying to find the surface area of the composite figure. And the surface of this rectangular prism is covered by the cone. So that means it's covered by this circle here, which I drew up here. And I need to remove that circle to get the total surface area. In order to remove the circle, I have to figure out what the area of this circle is, because I want to know how much area that covers. So the area of a circle, in general, is equal to pi r squared. Now this circle has a radius of 5, so it's pi times 25, which is 5 squared. Sorry for not showing my work. 5 squared is 25, so it's 25 pi. And if I want to approximate that, I'll plug it in my calculator, 25 times the pi, which is approximately 78.54 meters squared. So the surface area that I'm actually including in this composite figure is the total surface area of the rectangle minus the circle, because that circle's not on the surface because it's covered by the cone. So I will take 632 minus 78.54 to get the surface area that's covering the rectangular prism, which is approximately 553.46 meters squared. Okay, so that is the total surface that's included on the rectangular prism. So it's a whole rectangular prism minus this circle that's not actually on the surface. Now, the goal is to find the surface area of the composite figure, not just the surface area of the rectangular prism. So I found the surface area of the cone that's included, which was the lateral surface area only, which was this 204. And then I found the surface area that's included on the rectangular prism. In order to find a composite area, you just have to add them together because you want to include the total area of all the shapes included. So with that said, I'll take 204.20 plus 553.46. Okay, so that's the cone and the rectangular prism. Okay, I know I didn't draw those 3D, but you get the idea, right? And if I add those together, I'll get 757.66. And I always want to include my units, which we're talking about area, so it's meters squared. And that would be my final answer here. Okay, so moral of the story, if you want to find the composite surface area, you kind of want to look at them as individual shapes, but you have to consider what's actually on the surface and what shouldn't be included. And then basically it's like finding composite area of a flat shape, where you have to add up all the shapes together. But it's a little different because you're finding surface area, not flat area. Okay, so I hope you learned a lot in this video. Please ask any questions you have in class. And I cannot wait to see all your composite figures in the inflatable project.